Okay, this is a video on solving inequalities. And the cool thing about solving inequalities is that they're very similar to solving equations. You just have to remember one very important rule. And usually, often we graph a solution to inequality because it's often not just one point. Like in a lot of the equations we solve, the solution is just one number. Whereas solving inequalities, often we have a whole range of numbers. Okay, so if we have an equation like, I don't know, an inequality, I mean 4 minus 3 times x plus 7 is less than or equal to 4x plus 2. Okay? So, like an equation, whenever we, or like an equation, your goal is to get an x by itself on one side and numbers on the other side of the inequality. That way, again, we're rewriting equivalent inequalities that are easy until we get one that's easy to see the solution for. So do all the same things that we're talking about with equations. We're going to simplify one side if we need to. For example, in this, you could rewrite this as 4 minus 3x minus 21, which is less than or equal to 4x plus 2. Okay. And then we can simplify this further as 3x, negative 3x minus 17 is less than or equal to 4x plus 2. Okay, where's that? Doesn't look like an x, does it? Okay, and now the next goal is to get the x's together. Now we could go either side. We could bring the 4x over to the left, or we can bring the negative 3x over to the right. I'm going to, excuse me, add 3x to both sides. And we get negative 17 is less than or equal to 7x plus 2. Subtract 2 from both sides, and we get negative 19 is less than or equal to 7x. Divide both sides with 7, and I get negative 19 sevenths is less than or equal to x. Okay? So that's my inequality. You see how it's a range of numbers. So all the numbers, negative 19 over 7 would work, but also anything bigger than negative 19 over 7 will also make this inequality true. Okay, now just to make a point, I'm going to go back up here and say, what if we would have went a different way here? Okay, so instead of bringing the 3x over this way, I'm going to subtract 4x from both sides and see what happens. So we end up with a negative 7x minus 17 is less than or equal to 2. So then I'd add 19 to both sides, and I get negative 7x is less than or equal to 19. And now when I go to divide by negative 7, I get x is less than or equal to negative 19 sevenths. So notice I get the same answer as I did before, as far as the number goes, but in this case it's saying x is bigger than it. Over here, x is saying it's smaller than that. And that's the rule that I mentioned. When you're solving inequalities, you treat it just like an equation in all ways, except for if you ever have to multiply both sides by a negative number or divide both sides by a negative number. So you can see here, to get from this step down, I divided both sides by negative 7. So when you divide both sides of the inequality by a negative number, or multiply both sides of the inequality by a negative number, you have to change the direction of the sign. And just to make sure you understand that, think about this. We all agree that 2 is greater than 1. Right? But if I multiply both sides of that inequality by negative 1, I get negative 2 is greater than negative 1, and that's not true, right? Because in the negative world, bigger numbers are smaller. So that's the idea. Whenever you multiply both sides of an inequality or divide both sides of an inequality by a negative number, you have to switch the direction of the inequality. Okay, now to graph this thing. What does this look like when I graph it? So the way we graph it is we graph it on our number line, and we go out to negative 19 sevenths. That's the number that I'm interested in, right? Because that's the dividing line. And because there's a line underneath the inequality, tells me that x could be equal to this, or it has to be bigger. So when I go to graph it, I'm going to put a solid dot here. Okay. And then since x is bigger than negative 19/7, I'm going to go to the left. So I draw an arrow going to the left. I'm sorry, going to the right. Okay. So that's graphing. Now, what if this would have been negative 19/7 is less than x? Okay, it looks exactly the same. We have a little 7, except for there's an open circle here with an arrow going to the right. Okay, because I'm still saying x can be bigger than negative 19/7, but since there's no line there, it can't be equal to negative 19/7. So we put a little hole there. See here, it's filled in because it can be equal to that. Here there's a little hole because it can't be equal to it. And of course, if this would have been x is bigger than negative 19/7, well, that is what it is. If we would have had x is less than negative 19/7, well, then we would have had negative 19/7 here, and we would have put a open circle there and would have drawn an arrow going that way. Okay, so that's graphing inequalities. So when you're solving inequalities, the moral of the story is you treat them just like equations that you're solving, except for when you just have to remember if you multiply or divide both sides of the inequality by a negative number, you have to switch the direction of the inequality. And then also this bit about graphing you didn't understand. Okay, I'm trying to keep this one short.